In the early hours of Sunday, September 14th, 2015, a scientist in Louisiana makes a fateful decision.
The one up on
Robert Schofield has been working all weekend, doing final calibrations.
Alrighty, let's take a spectrum.
He has one last test.
So let's see where this computer is getting its power.
But it's late, and the equipment is not cooperating.
It was about 4 or so in the morning, and we still had about another hour of work to do. And we were like, yeah, things aren't working so well, and I'm really tired. Let's not do this last hour or so of work.
They call it a night, and 40 minutes later, in the silence of their inactivity, they open the door to history. A powerful gravitational wave rumbles through both detectors, Louisiana and Washington. Had Robert Schofield worked 40 more minutes that night with the instruments in test mode, a signal that had been on its way for 1.3 billion years would never have been recorded.
I like to say, you know, one of my biggest contributions to LIGO has been my laziness that day.
I got an email from somebody here saying, hey, you look at this place on the web. I looked at that, and I said, holy.
It was so strong that you could see it by eye in the data. It was too good to be true.
But it was true. In fact, it was loud and surprisingly clear.
And it just sang at you. There it was, standing out.
The signal lasted less than a second, but in that briefest of moments, it delivered a cosmically profound message more than a billion years in the making, proving the existence of black holes.
So what we saw in the signal involved oscillations of the mirrors that were slow at first, became faster and faster and faster. And this was precisely the kind of behavior that you would expect from gravitational waves caused by two black holes going around each other, spiraling together.
Two massive black holes, one 29 times the mass of the sun, the other 36 times the mass of the sun, whipping around each other hundreds of times a second, finally completing their act of mutual destruction by merging, creating a single, larger black hole of 62 solar masses. The violent merger converts some of the mass into an apocalyptic release of energy beyond anything ever before witnessed.
The collision, in effect, creates a veritable storm in the fabric or the shape of space and time. As though you had taken three suns, you had annihilated them completely, converted it into gravitational waves. The power was 50 times higher than the output power of all the stars in the universe put together, in a fraction of a second. But the most powerful explosion that humans have ever had any evidence for, with the exception of the Big Bang.
Since that very first signal in September 2015, LIGO has detected several more collisions of black holes. In October 2017, Ray Weiss, Kip Thorne, and LIGO's former director Barry Barish received the Nobel Prize. The LIGO discoveries prove that black holes can merge. One way they can grow bigger quickly.
More and more evidence of these merging black holes tells us there are a lot of these stellar black holes around that they can find each other and merge.
And the discovery opened an entirely new way of observing the universe.
We've always thought of astronomy as an observational field where we are looking at radiation. We are seeing things. But this is not radiation. This is something much more fundamental. These are sort of fundamental tremors in space-time itself. We can now hear the universe.
For the first time, astronomers have simultaneously seen and heard a cosmic event. In August 2017, LIGO detected gravitational waves from a collision of two neutron stars. Black holes are empty space, but neutron stars are dense, dead stars that can crash together and light up the skies. When telescopes and satellites around the globe pointed in the direction of the sound, the world saw fireworks in an explosive collision and afterglow. Possibly, the collision resulted in the creation of a new black hole. But unless we observe the formation of a black hole, there is much we will never know. Because so much about black holes is irretrievably out of our reach, we can never know where they came from, what's inside, or their history. But we can imagine their future. The number of black holes in the universe is increasing, and they're getting bigger. Stars collapse, black holes feed and merge, new ones form. Could it be that one day everything will end up inside them and they will rule the universe? Untold trillions upon trillions of years after this happens, and the last bits of matter cross their event horizons, black holes themselves may radiate away and vanish from this reality. Their mysteries are many, and we're just starting to unlock the secrets of these strange, powerful places. But one thing is certain: black holes will continue to intrigue us, tantalize us, and challenge both our science and our imaginations.